in this presentation, we are going. Excuse me, I think something's happened. I want to hide this. Okay. Now, can you see my slide here?
Yes. Slide is visible.
Yes. Actually, the talk is about the role of uncertainty in the AI. I mean, the classical AI, everyone knows about it. The classical AI works with uncertainty, but the types of uncertainty is limited. In this talk, we are going to talk about the mathematical framework of some spatial uncertainty, advanced uncertainty, let's say that meta-uncertainty, and their role in AI, artificial intelligence. Actually, I am not a specialist in the AI, but I know that how AI works and also how it can be used, uncertainty in AI to get a better performance. So, in the classical AI, we know that the AI reduces all uncertainty to the probability. But real world data is neither equally trustworthy nor well-defined. So it means that the probability is not enough to be known as uncertainty in the AI. So, for example, we say that blood pressure is high. There is vagueness, not a probability here. So we say sensor reads, for example, 37.2 degrees Celsius. So source is trust. Is the sensor reliable? We don't know about it. Risk is fairly high. Here is both of them, linguistic and also credibility. What we are going to talk about it is credibility, reliability here. So we to this end, we should talk about some spatial uncertainty. It calls Z-numbers. Z-numbers has been proposed by Professor Zadeh in 2011. And in these numbers as an uncertainty, the numbers consider the fuzzy set as a restriction and also the probability or distribution or density function as a reliability or credibility for the fuzzy set. It means that how can we trust the uncertainty? How can we trust the restriction as the uncertainty? So here the two-dimensional uncertainties will be discussed. As the statement can be precise but unreliable. So this is the brutal, or vague but highly trustworthy. Probability and mean conflicts both of them precisely and also the trustworthy, but Z-numbers separate these two concepts. And everyone knows that in normal or usual life, we consider also we think and also we discuss many words, uncertain words, the words about the precise word and also the uncertain words. And how can we trust the uncertainty? How can we trust your words? Maybe sometimes the device is precise, but how can we trust that this precision is right, is true, is correct, is reliable? So we are going to discuss about these things here that we are using in the AI models. As I mentioned before, the Z-number has been proposed by Professor Zadeh in 2011. For the Z-number, we have two parameters here, the order pair and A means that restrictions, fuzzy restrictions, normal fuzzy set, everyone knows about it from universe So set to the interval 0, 1 captures linguistic vagueness about the value. But what about the second parameter B, component B? It is about the reliability. I mean, a fuzzy credibility measure with another maybe fuzzy set. We say mu B from 01 to 01 captures low much the source of A should be trusted. In the Z value, we have indeed the X as a universal set, A fuzzy set, B. B means the probability of A. The role of B is how can we trust A? What is the, I mean, the reliability degree for the uncertainty A? So sometimes, I mean, in the classical definition of Z numbers, Zade introduced B as a probability of A. So what is the probability here? The probability is a function. So it can be a distribution function, yes. It can be a density function, yes. And also it can be a fuzzy set. I mean, A and B, both of them can have the role of fuzzy sets, but the difference is here. The fuzzy set B acts the role of probability of the fuzzy set A. We know that sometimes the probability functions shapes is a triangular or Gaussian functions. So in this talk, or maybe I can tell you in most of the models, because of the simplicity, the uncertainty as a reliability considered as another fuzzy set. So now this is some types of new concepts. Everyone, please note that in this talk I will talk about something new, and maybe they are correct, maybe they are not correct, but I think they are correct. So in the fuzzy set, we had the definition of the extension principle. Now here in the Z number, we should have again the definition of extension principle. Because extension principle talks about the distribution of the vagueness, distribution of the uncertainty. It means that if you have one operators and operators effects on two things, so what will be happening to the result of the operator? I mean, what will be happening? The uncertainty extended, affected by the operator on the two uncertain things. So in the Z numbers, we have two parameters. We say A as a fuzzy set and B also as a probability set. So they should have two types of extension principle here. The first one would be about extension principle on the restrictions. I mean, two components A1 and A2, because we consider here that we have two Z numbers, the two order of pairs, and one of them is A1 and B1, and the second is A2 and B2. So we have two fuzzy sets here, two restrictions, A1 and A2, and also two probability B1 and B2. So we should have here two separate extension principle definition. The first one for the, the restrictions and fuzzy sets, as you can see here, and the second one, reliability propagation here. So the difference between these two definitions is here. So in the first one, we have the normal function here. Say operator, I mean the operator, I talked to you about it. we call it by F, but in the reliability combination, I mean the propagations or the extension principle, we should use T norm instead of the operator. So here it means that we have a combination of two reliabilities, two distributives, two credibility. So we should measure this value by some norms. The T norms. T norms can be strict T norms or any other T norms we know about it. Sometimes we use minimum. So we have a combination of here the credibilities. So the degradation theorem about these combination, we say combined reliability always degrades. It means that we have this inequality. The combined credibility can never exceed the weakest input. It means that we have some upper bound on this indeed combined reliability. The direction of degradation is granted. I mean, its magnitude depends on the choice of our T norm. So what we can explain in this page, I mean in this slide card, each ZAI computation step propagates not only the semantic outcome, but also the reliability accumulated so far. I mean, elevating credibility to a primary object in every influence chain. So another combination of, I mean, not say combination, I mean considering meta-uncertainty. Let's say meta-uncertainty. Another uncertainty is type 2Z numbers. Again, I am talking about type 2Z numbers, and I think my thinking way is correct, but I'm not sure about it. So, as you know, we have type 2 fuzzy sets also. What is that, the type 2 fuzzy set? The type 2 fuzzy set is a pair of two fuzzy sets. So it means that the membership degree are themselves again another fuzzy sets. So a membership degree has another membership degree. So we can say that, maybe we can say that in the complex way. If you have fuzzy set and each X from universal has a membership degree, that membership degree has another fuzzy set. So this is the fuzzy set, I mean the power fuzzy set, something like this. And the difference of type 2 fuzzy set is very different from the definition of the Z sets. So what about the type 2 Z numbers, type 2 Z sets? So here in the Z sets, we have again two components, A and B. So the formal definition for the type 2 fuzzy set, we have indeed membership function. For restriction A, one knows about it. This is, and another one, mu B, is a membership function from. Look, the difference is here. The domain here for A, mu A is X universal, but the domain for the mu B is interval 0, 1 as a range of the indeed mu A. So the both ranges are the fuzzy numbers, fuzzy values, I mean ambiguity between 0 and 1. So a type 2 fuzzy number, Z numbers, is formally expressed as a 2 component here. Again, the first component is, as you can see here, the normal fuzzy set, and the second one, as you can see, another fuzzy set. But another fuzzy set affects on the indeed the range of the first one. So Secondary great function here, I mean the B, as you can see here, is a routine or normal set, and for the simplicity, for the smoothness and differentiability aspects, normally in the AI system we can consider as a Gaussian function, because the Gaussian function are smooth and also differentiable. So this is why this is a routine membership function. So here we have the definition of type 2Z numbers. So we need two secondary membership degree or membership function. So if we want to consider why we should define the type 2Z numbers, because in the interpretation we can say that we have two membership functions here, mu A and mu B. So easily we should consider the interaction between these two functions. So what is that? One of them is assertion. It means that mu x show strongly x satisfies A, and narrow secondary split means a confidence. So we have about the satisfaction, and how we talk about the confidence of the satisfaction. Credibility is another part, is the trust of the grade. So we have two concepts here. The one related to the mu A, the second related to the mu B. So we should have different cases of these two membership functions. So we have 4 cases. We say high mu A, but narrow mu B, high mu A, wide mu B, low mu A, wide mu B, low mu A, and also narrow mu A. For example, if we say low mu A plus wide mu B, it means that this is weak and disputed, but discard or flag. So what is that? Wide mu B. I mean, the credibility is the wide function. So, and also, what is about the restriction? What about the uncertainty? It is weak and also disputed. So, this chart, it should not be considered. If we say high mu A and also narrow mu A asserted, okay, that's good. Highly trusted, that's good, because high mu A we have act on this outward. So high trusted, narrow mu A. If we want to talk about the credibility, trust, so we should have narrow extension. Narrow extension principle, narrow membership function about the second part of the numbers, because everyone knows that we use the minimum. If you use minimum continuously, it should go to the 0. So this is another problem for the Z numbers, and this is indeed the open problem for the numbers, because in 2011, Zade talks about the operations on Z numbers, and he used the minimum operator for a combination of the second part of Z numbers. So if you use, for example, a finite number of Z numbers, you have to use the operator minimum immediately and also continuously, steadily. So what will happen in the end? It should go to the 0. So it means that if it should go to the 0, it means the credibility or trust should go to the 0, and it means that finally it is going to converge to the what is said. It means that if you use the computations on the certain number of Z numbers, finally you will have a fuzzy result without any credibility and reliability. Yes, this is the problem. This is the open problem for working on Z numbers. So this is why here we say that narrow mu B, but high mu A would be the better case. And so if we have the indeed Z numbers, and if we defined type 2 Z numbers, we can define interval type 2 Z numbers. So why we should define it? Because it is traceability. Full type 2 requires integrating our fuzzy set at every step, but interval type 2 Z number uses interval arithmetic. So interval arithmetic is dramatically cheaper in the computation case. And also in the final result, instead of output interval, we can use some midpoints and also the other things to give the results. And also the interval computations here, interval uncertainty captures expert hesitation educatively for medical, engineering, and decision support applications. So here for the interval type 2 Z numbers, we can define the footprint of uncertainty. What does it mean, footprint of uncertainty? We have the components for A and also the components for B. What kind of components? So we have A and B, two fuzzy sets, and everyone knows that every fuzzy set can have the again credibility. I mean the level-wise sets. I mean the alpha cut, some cuts. So we have a set of intervals corresponding to the fuzzy set. So in this case, we can show the fuzzy sets, but the intervals for each interval we have 2 points. I mean the first bound and the second bound for the interval, lower bound and upper bound. So in this case, we will have indeed lower bound and upper bound for each of the sets A and also B. So for Z numbers A and B, here we have the intervals for A and also another intervals for B. Indeed, interval type Z numbers is the standard form in ZAI implementations, mathematically honest and computationally variable. So this is why we can use the interval type Z numbers. And all these topics are, I mean, there are new concepts and everyone can work on. So I just want to introduce these new concepts here. There are lots of things that we can do on the interval type 2 Z numbers. For example, using these definition, the differential equations, interval equations, in the AI, in the machine learning, in the optimization problems, many things. These intervals and also the type 2 Z numbers. There are open problems, many open problems in the optimization problems about the type 2 Z numbers and the interval type 2 Z numbers. So everyone can work on these topics. So here is the AI architecture. We know that we have 4 stages here. The first one is on the data, expert rules, sensors, streams, and language, and all of them are mapped into the Z form of numbers, capturing both content and also source credibility from the start. And in the second stage, we have Z evaluation, I mean restriction and also reliability. Both of them represented as a fuzzy numbers here, linguistic or hybrid objects, preserving the 2-dimensional uncertainty structure here. Yes, I mean the 2-dimensional, because we have 2-dimensional evaluation A and B. And the third stage is about the inference. Rows and optimizers weight not only plausibility but also source trustworthiness, credibility propagate through every result step. So this is some kinds of the indeed this is the important. I mean, this is the mind of the any rule-based systems, any AI system, inference, logic. This is the logic. So after inference, we should have a decision. So in the decision, with this data, with this inference, and also the evaluation outputs are robust, interpretable, and selectively cautious, because the system can abstain or differ when credibility support is inadequate. So in general, ZAI, it is not a single algorithm. It is the mathematical layer of all the learning, reasoning, optimization methods. Its design is guided by 4 fundamental operational questions. So we have here aggregation functions, ranking methods, learning systems, and also explanations, which treats reliability as primary quantity on equal footing with underlying semantic information. This is the general structure for the AI, but here we consider the data and also inferences and decisions by the Z concepts. So the first thing that from the 4 stages that we can consider is the learning on the reliability and uncertainty. So this is the formula for the learning. So in this formula, we insert, we involve the reliability as Z numbers. So before talking about the learning with the Z numbers, we should think of how can we use the credibility here. The learning function credibility here is acts as a weight. So here it is as a weight. So we can have lots of explanation here. N is a total training samples, L here per sample, loss function, cross entropy or anything, and mu is a credibility weight, scales, samples, I's contributions, and in the special case, if we say that mu b is 1, the credibility, reliability is 1, so this is perfect. So full contribution. But if we say that mu b is 0, no contribution, because we don't have any second part. So here we have some cases for the data and also the uncertainty and reliability. If we say that clean plus credibility weight is 1, so full contribution to the loss, yes. Uncertain but trusted, medium credibility weight, partial contribution to the learner. So because we say that uncertain, so medium credibility weight, but trusted, okay, partial contribution to the learning, because the contribution to the learning means that the coefficient in the learning functions, and the coefficient in the learning functions is a credibility weight. So we say noisy but unreliable. Credibility weight is 0. Okay, automatically down weighted regardless of the precision because it's noisy. So hybrid models all operates naturally on Z-valued inputs. Trust-aware, loose terms, adaptive penalties, and label confidence shaping are all expressible within the ZAI framework. So again, this is the second, the continuity of the previous slide. Again, here is we have input and outputs here as a Z numbers. We you can say features and labels here in the AI. So what about the gradient vector updating here? So this is the updating rule for the gradient. And so again, this is combined, this is explained, formulated by the learning function that we talked about in the previous slides. So here, each sample, xi and vi is lifted to the zk samples. Features and labels both carry a fuzzy value and the trust score. And also reliability, low credibility samples have proportionally less effect on theta. Yes, because it shows it. The update is scaled by this weight, credibility weight. So this is the simple form for the updating the gradient rule in the learning system. Apparently, for the future, we should have some formal representation or presentation for the inputs. So here, this is the inputs. Here we can show it by the D numbers of the inputs or the features here, and we have two parts again, and each members or each element is shown as a Z number here, and we talked about it, and in each two second components, Bij I mean, downweights features influence, unlike classical vectors, which treats all input as equally trustworthy. So here, for example, we say high trust feature, the sensor reading with Bij approximately 1. Yes, because trust feature. So we should high trust feature. We should consider the second part approximately 1. Fully trusted contributors with full weight to the prediction. So if we say low trust feature, it means that the Bij must be 0 approximately, a self-reported value with the Bij approximately 0, downweighted during inferences, preventing it from dominating, because in this case it should not have any role in our inference. So every feature contributes through both its linguistic value Aij and its source trust degree Bij. This is, two-channel encoding. But if we have uncertain AI with normal fuzzy sets, we have only one channel encoding. But here we should have separately two-channel encoding with considering 4 cases of involving a combination of the uncertainty. And the same things we can claim about the output or label confidence. Again, labels or outputs are Z numbers. So if we say that the second part is approximately 1, full contribution, high agreement, credible source, the label is fully trusted during the training. So, but if we say the second component Byi is, for example, 0.5, in this case, partial contribution, some disagreement between a non-dictator and also the label contributing proportionally. So there are disagreement between these two things. And if we say that the second part approximately is 0, which means that non-zero contribution So it seems that my time is
Sir,
over, sir.
not over, but you can
Yeah,
continue and complete within 5 minutes. If you wish,
okay.
otherwise you can take questions.
So I have 5 minutes, yes?
Yeah. No.
Okay, I'm going to finish it. Learning with type 2Z numbers. So again, we can use the concept of interval type 2Z numbers. I mean, we can have a cut on the gradient functions, gradient rule, and also the learning. So in this case, we should have lower nabla and those point of these lower and upper nablas and use it as a updating of the gradient rule. So in this case, we can consider the several cases of the credibility and the trustworthy and also the uncertainty. What is that? So it means in the Z numbers, we consider crease for fuzzy scalars, but type 2Z numbers, intervals. In Z numbers here about the gradient weight, we consider single mu b, but the interval, but type 2 is an interval bonded gradient. This is some advantages for these two new concepts that I propose in this presentation. So what about the optimization? Everyone knows that we have an optimization problem here. So we should work on it. And now what about the optimization problem when we have some Z input and outputs here? So here we can set our objective function subject to the, for example, lambda phi bx. Bx credibility penalty, penalties low reliability solutions, and other parameters that we can consider here. And as a standard optimization problems in this AI, we can consider that they must be Z numbers. So again, we should have our inference and also reasoning systems. I mean the decision part. So decision part should be done by some norms here, and in this decision system we should consider both A and B, both parts of Z numbers. So again, we should consider all here. You can see that Z inference, reasoning, they are easy to find and also to prepare, because everything, some things are the same, the definitions about the norm, but the combination is different because we work on the two parts here. And also application, the decision support systems, supply chain, healthcare, diagnosis, and also triage, mining, engineering. We have some applications here, healthcare, and some books, and also the decision support systems. Especially our university have lots of data on the healthcare systems, and we can use it on the in this line. So again, the benefits, and during my talks, I talked and explained the benefits of the indeed ZI. And thank you. Artificial intelligence becomes more humanly usable when it can distinguish between uncertain knowledge and unreliable knowledge. So this is about, these talks about the uncertain knowledge and unreliable knowledge. Thank you very much.
Thank you, Professor. First, I will ask the audience, please share your questions. Participants, you can ask questions.